What is up? What is happening? Good morning, good evening from wherever you're tuning into because you are here at the Red Hat channel joining for one of the best series that we have, which is called Demo Deep Dive, where we talk about some of the open source projects and the technologies that are part of the open source world, but also powering innovations in AI, powering innovations in the Linux ecosystem and in Kubernetes and in Ansible and all of these other types of technologies that power pretty much our modern world as we see it today. And so you're going to learn how things work specifically on this series. We're going to get into the actual demos of these different types of software. And we have a lot of different episodes in the past. If you're interested on cluster management or Ansible automation or AI, and AI brings us to the subject of today. So I've got a very special guest today. We're joined by Sean. He is the principal technical marketing manager for ACS. He's a member of the
OpenShift
Red Hat
Security.
team. Oh, yeah. Hey, Sean.
OpenShift Security, not ACS. Michael Foster is the TMM for ACS. I do OpenShift Security.
OpenShift Security. Okay. Which is even cooler because we're going to be talking a little bit about how AI is being used to, or how security is used to secure these workloads in confidential containers. And so it's going to be a lot of cool topics that even me, I'm not familiar with. And so we're going to try to break it down to you because AI models are some of the most valuable IP that we have out there. So how do you actually protect a project when you're running them in the cloud? And so, Sean, feel free to give a little bit about your background and what you've been working on recently.
Sure. So for those who don't know me, my background does come from more of a offensive security kind of focus. So I've done red teaming, I've done blue teaming, spent almost 10 years as an SA for the competitor. Oh, my camera decided to die out on me. That's fantastic. Yeah, and basically now I do OpenShift security, and I'm going to fix my camera in just a moment. Apologies for that. We call that Murphy's Law, right? Uh, and today I've been doing a lot of arcades and interactive experiences for the last little while. So that's kind of what I do now.
Awesome. Yeah. And when we mention any of these interactive experiences, you can actually scan this little QR code up here. It'll bring you to a site called interact.redhat.com where you can actually go through and check out all of the different demos for technologies and kind of patterns that you're interested in. So maybe it's about operators on OpenShift, or maybe it's about AI automation and pipelines, right? Using projects like Kubeflow. And so the basis of it that I really love is that all of these are using open source projects under the hood. And we're able to take these, productize these, and that's kind of what Red Hat does, right? Is we kind of make these technologies mainstream for the enterprise. And so when you see the demo today about security and about confidential containers, these are all coming from upstream projects that Red Hat contributes to, and you can check out how these work and get the demo if you just come over to the QR code here and check them out yourself at interact.redhat.com. So without further ado, I guess we'll go ahead and kick it off. If it's all right with you, Sean.
Absolutely. Yeah, my camera decided to just die. So that's fantastic. I'll have to find out why later. But the good thing is that we can still go through the demo, and the demo is more important than my face. So that being said, a month or so ago, I was contacted by the team around confidential computing around a demo that they were creating for GTC. The whole idea was to showcase how our solutions allow for the trusted access to AI models through OpenShift using NVIDIA's technologies. So they approached me. They said, "Hey, we've got this demo. Do you think you could help us out with making an interactive experience?" I said, "Absolutely. Let's go ahead and do that." And so this interactive experience was created, and the whole idea is really to show off the idea that zero trust is possible in AI, and it's not a theory, but it's actually something that is possible today. The environment is actually running on Red Hat OpenShift in NVIDIA's environment. So we're actually using NVIDIA H100 confidential GPUs. So we're these tens of thousands of dollars GPUs to do AI stuff, and we're actually able to achieve total workload isolation using that.
Awesome. Yeah.
So the whole idea is to be using hardware encrypted memory. And that is actually attained using a couple of different things. We do use, I'll be showing it off more in the demo itself, but we're going to be using kata containers in there, as well as some calls using NVIDIA's own proprietary infrastructure to be able to attest for the hardware that's actually running. So,
And real quick, Sean, before we hop in, so I just got like two quick questions. So zero trust, what does that mean? Like we don't give any access to the models? Like how does that work?
so yeah, zero trust. That's a term that, as an offensive security guy, I don't like, because it's not truthful, I would say, because everything does require some level of trust, and the whole zero trust idea is it should be renamed to least privilege trust, or least amount of trust. But yeah, it is still doable because of the way that we're doing it. We're kind of doing a shift left to the point where we're not allowing. We're doing the reverse of what is standard in terms of giving trust. So instead of starting off with trust being given, we're starting off with trust being rejected, and then only applying trust to the particular workloads that require that trust.
Gotcha. Okay. Awesome. Thank you.
So what's important when creating interactive experiences, it needs to be something that can be used either on the fly during a keynote, or even as a backdrop in a booth, right? We want these demos to be something that that can be repeated and can be used in multiple different areas. So lots of text in this one, because these are kind of complex theories that we're using. But the whole idea is that we're going to be using the NVIDIA inference microservices, or the NIM container, and we're going to be using one that is completely unedited. We are not changing any of the stuff. We're running it right out of the box.
Mhm.
And because this is a 100% unmodified standard NIM container, we're actually able to showcase that this trust can actually be created without any further editing or any sort of configuration. So the whole idea is that the API key to pull the proprietary model is what we're going to be protecting. The model itself does reside on, so basically in this environment we've got two different clusters. We have an untrusted cluster and we have a trusted cluster, and the model itself is living in the trusted cluster. But the whole idea is to be able to pull that in a quote unquote secure method to be able to ensure that it's not edited or it's not accessed by actors that might want to do bad things to it.
Gotcha.
So we've also created so this was created by the PMs that I was working with, a little bit of a diagram to show how this actually works, how the NVIDIA NIM container is deployed via a confidential computer, and how it's actually used. So in the current unsecured deployment, you're going to have the user that's accessing the NVIDIA NIM container, and we'll be able to kind of have arbitrary access to different things, to download, to alter, and to redistribute. In the proposed secure confidential container deployment, that is actually all being handled by the NVIDIA Secure Server. So the user access is restricted. The user actually never accesses the model directly, and everything is actually handled via the NRAS and the NIM. So the keys are injected directly into the encrypted memory. The admins, hackers, and anybody can't actually never get to see them in plain text. We replace months of legal security reviews with an automated mathematical proof of hardware integrity using the NIM container, and the NRAS, which is the NVIDIA Remote Attestation Service, provides the verifiable and tamper-evident records required by regulation like DORA without any sort of manual sign-offs. So we're removing that human element to ensure that these steps in security are handled the same way every single time. And this is another end-to-end diagram that shows that the hardware proves its integrity for the GPU to the NRAS via the trustee, and the CPU to the trustee. The NRAS will evaluate the security policy automatically, and the trustee will drop the API key straight into the enclave's shielded memory. So again, the API key will not be seen by anybody. It will just be dropped directly into that shielded memory to be used by the services. So here in our environment, we do have a secure server. So we simulate the model provider NVIDIA running the Red Hat build of trustee, storing the user access key. So showing the installed operators, we want to show that this is the trustee operator. In our workloads and in our pods, we can show that the instance is running, and that in our config maps, we can see different things. And more specifically, when we scroll down quite a ways, we have this attestation service verifier. So this shows that the attestation service is a remote type, and it is being verified by nras.attestation.nvidia.com. So that entire attestation is being done directly by NVIDIA to attest for the hardware that they're running. So the trustee is configured to perform directly with the NVIDIA NRAS. Now, going to our trustees, into our secrets, we do have our API key here. And this is the user API key. This is ready to be returned to the confidential container pod if the attestation is successful. Going back into our operator, we're actually going to show the KBS config. And this is actually one of the cool things about this entire thing, because this is running in OpenShift, because this is a Kubernetes based thing. Everything is pointed out and pulled in via YAML. So this NVIDIA API key is right here in our secrets resources. If we go down into our untrusted cluster, should I say? Here we have a H100 single node OpenShift node running OpenShift. And if we check into our YAML and scroll down, we will see one thing that is unique. It's a bit long. Here we go. And it's this part here. The nvidia.com/GPU present equals true. So this states that we do have an NVIDIA GPU that is present within the node.
Mm.
And if we go into the NIM pod, and into our YAML, this is where we actually declare our security guarantees to OpenShift. So the example that we're running here is actually running this Llama 3.18b instruct model. And we're going to see that being called out here in the YAML down a little bit further. And there it is. So if we look at image here, we'll see that it is indeed the Llama 3.18b instruct latest. So that is the model that we are using. And if we go up a little bit in here, we're actually going to see our runtime class here. And this is where you see that Kata confidential container being called in. So it is a Kata container that is being run with an NVIDIA GPU. So this tells OpenShift that this workload has to be run inside of a hardware isolated enclave, meaning that the GPU and CPU are partitioned off at the silicon level. No other process and no system administrator can read the memory of this pod while it runs.
So is this like a software thing or a hardware thing where like they actually solder off the read and write for a particular part?
It's a bit of both. So the software is the part that it's is making that separation, but it is relying on the hardware to create attestation for access to it.
Very cool. Yeah.
And now if we look over here, we do have our CC init data. So this init data is what actually calls out the information for our confidential container. So this is all encoded in base 64. So it is not encrypted, it is encoded. Very important to make that distinction. But basically, it will actually execute in the interest environment. It'll make sure that what is executed in the interest environment is untampered with and protected in the TEE. So it is versioned as code, and this policy provides a transparent, auditable trail for compliance teams to prove data in use protection. If we go down to our secrets here, we have something called a sealed secret. So basically, the untrusted host only sees a pointer, which the confidential container automatically swaps for the real key. Because if we actually go in here and go down to reveal values, we're actually going to see that it is a sealed fake value. So we never actually see the real key. And that provides another layer of protection. So by using these sealed secrets, untrusted hosts only sees a pointer, which the confidential container automatically swaps for the real one. So if we go back to our NIM pod and into our YAML and scroll down, we actually see here that we are calling our reference key, which is that sealed key there. So it requires no modification because it simply pulls an API key from a secret, remaining indifferent to the underlying retrieval process. So the entire thing is done automatically. And I hate that word, but it works for this one. And it verifies that the CPU and GPU are actually that are running are actually genuine and unmodified. So it's attested. It is attesting. There you go. That's the word. Attesting for the validity of the hardware. So let's switch back to our trusted cluster and see how the KBS receives the attestation evidence. So down in our trusted cluster, we take a look at our logs here, and we'll actually see that we have our verifier endorsement check pass. So our TE is in PTE class CPU and NVIDIA TE class GPU have both been attested and verified to be exactly what we want here. So this shows that the trustee successfully checked both GPU and CPU and ensure that they are untampered and provide a secure environment.
Interesting. So this pod, though, it's not the model running. This is the workload that does the checking, and it's just always running, or how does that work?
Yep. So the workload that's currently running in the background is running the attestation. So it's checking
Mhm.
into the NRAS and making sure that the hardware has been signed off.
Mhm.
And this is just the NIM pod.
Gotcha.
So this shows that the secret requested by the container policy are actually returned, like the signature verification. And this last one is really what we want to look at, the API key. So NVIDIA API-key. From the model vendor's perspective, their IP was never exposed. From the enterprise perspective, the AI inference is now running with a proverbial hardware security guarantee. So for the end user, this complex security remains entirely invisible. The end user does not see it, and if the end user does not see it, neither does the administrator, and neither could a bad actor when they try to gain access to it. So let's say take a look at how the confidential container policy is enforced. If we take a look at our logs here, you'll notice that the logs are disabled, so information cannot be gained from them. Not only that, if you look into our terminal, the terminal access is also denied. So that complexity is invisible even to the developers. If we go down to our routes here, the model is exposed as a route. And we configure, and using that route, we actually configured a simple open web UI interface so that we could actually gain access to it and work with it. And if I do that and go into there, we can actually use the model. So log in as our user. And at the top here, we do see that it is exactly the model that we had talked about before. So that llama 3.1 HB instruct. And it confirms us two things. First, the hardware enclave is real and actively processing, and the performance overhead of confidential computing is minimal. We're not sacrificing throughput for security. And let's ask it a question. Say, what are Red Hat confidential containers? And there you go. It spits out an answer, and as you can tell, it's very, very quick. So that overhead for confidential containers is incredibly minimal. And that's it. So basically, a model vendor shipped an encrypted model, knowing that their IP is mathematically protected. An enterprise ran an AI inference on sensitive data, knowing it never left the encrypted enclave. And a compliance officer can point to an NRAS attestation record as evidence of hardware integrity. And the developer wrote exactly the same API call that they always would. So that's basically what Zero Trust AI looks like on Red Hat OpenShift.
Very nice.
QR code for next steps. So there you go.
Yeah, it's great. It's great. It's kind of a win-win situation for the platform team and for the developer team, that devs don't have to change their code, but the platform team gets that assurance of, hey, we know what we're running. Because nowadays, we're downloading models from Hugging Face, from GitHub. You can't really inspect the source code. So I feel like having this type of attestation and management of the models is really important if you're trying to deploy 50 different models to do 50 different tasks. Right?
Absolutely.
Nice. Well, this was a great demo. I really appreciate it. And I think if you're interested, where does the QR code lead us to?
So the QR code should lead you to confidential containers on OpenShift. So it should be an article that's been written by our awesome PM team that handles confidential containers.
Nice. So with Zero Trust, I mean, how does it apply in this whole kind of overview of what we've been doing?
Well, since AI is an important aspect of Red Hat's strategy, we need to ensure that we are offering the same level of enterprise grade security that we always have. So having confidential containers available in this frame allows us to work with our AI partners to create really solid levels of trust and attestation between the hardware that's running, the model that's running, and the way that we're presenting these AI models. So it's part of what what anybody should be thinking of when thinking about enterprise grade security.
Nice. And I guess we're talking about AI here, but this also applies to regular Java, JavaScript applications, Python applications.
Yeah, it can work with a bunch of different things.
Cool. Very cool. Well, awesome. I guess we'll kind of start to wrap up here, since we went through that really cool demo. I've got on my side of the screen here a page here about where to go next for OpenShift and OpenShift security. So feel free to check out your Red Hat page, because we've talked about Zero Trust here, but there's also vulnerability management, so CVEs on your images, and how you can kind of tie this all together in the app side, but also in the model side too when you're building these AI applications. And then also, here we go. I'll show the page again for the interactive demos. So if you're looking to try or repeat what we went through today, feel free to check out these interactive demos. And specifically, what's the name, Sean, for the one that we just went through? Oh, no worries. We'll find it together. But definitely scan the QR code, check out those demos. The ones on security were really cool, especially myself. I typically just kind of stay in my developer lane. And so learning about these security features that sometimes I don't even realize, like what we went through today with getting the same endpoint, but not realizing it's had that attestation, is really cool to understand how all of the different parts fit together when you're building these applications. So we'll kind of wrap up here. Sean, it's been a pleasure having you today on the show. We've also got Rohan behind the scenes making sure everything works properly. And we'll see you guys back again here in 2 weeks for another lovely episode where we're going to cover these open source topics on a deeper level, show you what's actually happening and how it works. But Sean, anything to say before we hop off? That's okay. I'm sure he would have said it was a great time. So thanks, Sean. Thank you guys for tuning in, and we'll see you again in just a few weeks. Cheers.